Well, good morning, everyone. We have a very special guest with us here today, Degioanni. All right, I'm seeing the hands, they're telling me to lift the microphone up. I'll try to do that and remember to do that throughout the talk. Anyway, yesterday I mentioned that we have a new sponsor, the project does, and the conference does as well, Sysdig. And I also mentioned that Sysdig does cloud security, and maybe that's not obvious. The connection there might not be obvious, but I also mentioned that Sysdig was founded by Degioanni, who does have a strong connection with both SharkFest and with Wireshark. Loris was one of the original authors of WinPCAP, which helped us to run on Windows, which is a very important step in the growth of the project. He was one of the co-founders of Case Technologies, which was the project sponsor from 2006 to 2010, and cases where SharkFest came from.
I think the first SharkFest we were on the stage together is SharkFest #1. Yeah, right?
I believe so. But since then, and maybe you want to provide better details than I can. Anyway, since then, he has started an open source project called Sysdig and a company called Sysdig. And maybe I should hand things over to you and let you kind of continue that story.
So essentially, Gerald introduced me by telling you folks that I'm old. Thank you very much, first of all, for having me. I want to start by saying it's such a pleasure to be to this event that is always special. And yeah, I've been involved with it for a long time. So being back on the stage is definitely fun. And today, Gerald and I are here essentially to tell you a little bit about what we've been started working together in the recent months. And one of the reasons why Gerald joined Sysdig, which is the company that I founded a few years ago and that I work for. And of course, since we were talking about all people, we start from a story that starts in the very old days, right? And actually, I started working on WinPCAP for my graduation from Politecnico di Torino. I was still in Italy at that point I believe in 1999. So this is actually what networks were at that point, and they were actually coaxial cables that were connecting multiple computers. And so capturing traffic from the network in promiscuous mode was actually a matter of tapping on that single wire and seeing whatever everybody was doing on that wire. During those days, essentially, and before, essentially, we started doing open source. You were capturing packets with devices like this. This is, I think, a Redcom. It's funny because while looking for this picture, I went to eBay, and now you can buy one of these for like $30 or $40. At that point, you needed to be rich to own one of these. And essentially, the way I started, and probably Gerald started too, in the world of packet capture and network analysis, is because we could not afford one of these, right? And probably the first time people downloaded Ethereal or WinPCAP or one of our tools is because they couldn't afford or they didn't want to buy one of these. And yeah, essentially, initially with TCPDump by Van Jacobson and Steve McCann, and then with Ethereal created by Gerald and WinPCAP originally created by me at Politecnico di Torino. That was sort of a revolution, a new approach, right? So instead of using hardware to do your packet collection, essentially, this is a little bit of a modernized version of the original BPF paper that still now is essentially the common architecture in the kernel of an operating system for packet capture, and something that defines essentially the libraries at user level for packet capture, including the libpcap library that is used by so many tools including Wireshark, but many, many more. And this was essentially a matter of finding a way to put your network card in promiscuous mode, so in a way that would not filter all of the frames that were coming, the frames that were coming to accept only the ones that were for the NIC driver for the interface card of the machine, and then defining essentially a way to get these packets, store them, and ship them as fast as possible to user level, so that tools like Ethereal at the time, but many other tools could consume them as fast as possible. I was one of the founders of Case Technologies, as Gerald was mentioning, and we spent several years during those years. Case was started in 2005. Gerald joined in 2006. Wireshark was born in 2006 as well, in May of 2006. I don't know how many remember the change of name. For us in Davis, California, it was an exciting and dramatic time.
And scary as well.
And scary as well. While working with Gerald at Case, I started realizing that packets are a powerful data source. Packets never lie, right? But packets have some interesting properties. They are very rich of information, especially when you can decode the content, look at what's inside the protocol, maybe going up to layer 7 by looking at what the applications are doing. Packets are sourced not only to troubleshoot networks, but also to understand what applications are doing, to figure out attacks, to do threat investigation, to do forensics and troubleshooting, to do performance management, and so on. Packets see everything. If something goes on the network, you can absolutely see it. Packets can be collected with minimal overhead. We always underestimate the power of the spam port, you know? And the power of the spam port, I will talk a little bit about it in a second, but it's something that I wanted to emulate when I started working on modern stuff like cloud security and container security and so on. Just having essentially something magic that you can use to mirror all of the information in a separate port that you can use essentially to collect your information. Packets don't require invasive instrumentation. You don't need to link libraries typically. You don't install daemons. You don't need to do stuff that involves treating the devices that are connected on the network as something different than black boxes. And this is, again, very powerful and very unique as a method of instrumentation. If you think about both from performance and from security, most of the other ways of instrumenting stuff typically involves installing something, which has a couple of issues. One is every time that you involve something, you need to do work. You decrease the performance of what you're observing, the Heisenberg principle, but also installing something requires intent, right? So packets are very good for security because you see everything no matter what. You don't need to ask the developer, okay, link this library to your application, otherwise I will be blind. Same with performance, you know, when you need to collect data to troubleshoot an issue, you can do that with an instrumentation that is independent from the person that is actually owns maybe the specific device, the machine, the phone, the server, and so on. And that's why packets are at the base of so many classes of tools, right? So my history changed in trajectory in 2014 when after we got acquired by Riverbed, who's been the sponsor of Wireshark for many years, I decided to leave and focus on, again, the concept that the world was changing. At the time, AWS was really started exploding in popularity, and the enterprise was really starting considering seriously the move to the cloud. It's funny because now it's just so widespread everywhere, you know, and there's not even the concept of doing something different. But at the point is when, especially in the enterprise world, the bleeding edge people were starting moving to the cloud. And at the same time, a small company called .cloud was renamed into Docker, and the container revolution was starting. So it was very fascinating about the change, about that inflection in the industry. And I approached that inflection from the point of view, okay, I spent the previous 10 years of my life doing packets, and there's some really cool properties in packets and some really interesting and useful workflows. Just the concept of a trace file, you know, it's so powerful. We just assume it's there, you know, but somebody had to invent the concept, define the pickup format, and make that into a world standard that we can all use to exchange data, right? So can concept like this, the concept of deep visibility, granularity, no intent, and so on, be applied essentially to the new world? Because there were challenges. For example, where is the spam port? You know, when you are renting instances, computing instances from Amazon or Microsoft or Google or IBM and so on that are floating in somebody else's cloud. Where's the network wire that you can tap? So from this point of view, essentially what was on my mind is it possible to emulate something like this architecturally? And what I came up with is what is still now essentially one of the core pillars of the instrumentation that we do at Sysdig. Essentially, Sysdig collects events from the kernel of the operating system, in particular system calls, but tries to do it in a way that is as close as possible to what we do with packets in tools like TCPDump or even Wireshark. How does that work? Typically, by the way, this is created to run in modern computer infrastructures that typically tend to be based on containers. So for example, this slide is a simplified diagram of a machine that is running 3 containers. And you deploy the Sysdig instrumentation normally by running another container. There are ways, for example, with Kubernetes to tell Kubernetes, okay, I would like to have one of these containers on all of my machines. If it goes down, bring it up again. It's this concept, for example, in Kubernetes is called the daemon set. And by using a daemon set, it's very easy to essentially deploy one and only one of the instrumentation containers on every machine. The instrumentation container recognizes essentially the operating system of the machine that is running on, and deploys something in the kernel of the machine. Originally, in 2014, when we started, that was a kernel module. So something in spirit very similar to the Win pickup that I was describing before, with a very similar architecture. So that was interesting because this kind of instrumentation at the point was more like the domain of running scripts inside the operating system for technical troubleshooting. There were tools like dtrace that allowed you essentially to create a little program that would be injected in the kernel of the operating system, and then tap into facilities of the operating system, for example, trace points or kprobs. These are all places in the operating system where you have little hooks and you can go collect information. We decided to leverage a facility in the Linux kernel called trace points to essentially collect system calls. What's a system call? System call is the API that processes use to talk to the kernel of the operating system, and as a consequence to talk to the external world, to talk to other processes, to talk to other entities on the network, to do inter-process communication and so on. So opening a file or closing a file that generates system calls, open and close. Reading or writing data on these files, those are system calls as well. Inter-process communication, system calls. Connecting the connect system call to establish a connection or the accept to receive one. These are all system calls. So by collecting system calls, it's possible to live in the kernel of the operating system and get a very detailed and granular collection of the activity of every process that runs on the machine in a way that doesn't require to do anything with the processes. Actually, since containers are essentially processes that are running on the same machine, isolated by kernel constructs like C groups and namespaces, but in practice, a container is a group of processes that are running on top of the operating system, and the operating system makes them believe that they are the only ones, but they are still sharing the kernel of the operating system. So by sitting here in the kernel of the operating system, you can essentially collect data from all of the different containers with the proper context, so treating every container as an individual entity, but without having to do anything inside the specific containers. This probably reminds you a little bit the concept of spam port that I was describing before, right? And the fact that with the spam port, you can see all of the different machines on the network with just mirroring the packets on the port. So very often I call this kind of instrumentation the spam port for system calls. And nowadays, this kind of instrumentation, actually, we do it with eBPF, which is just the evolution of the original Berkeley packet filter that was designed to implement packet capture in the BSD Unix kernels. So it's interesting how really history, from one point of view, repeats itself. And it's also the things that were designed during those years were so well designed that they can keep being reused for different purposes. So system calls. So now that you collect system calls, you know, our collection system acts a little bit like a capture driver, takes system calls, puts them in a share buffer. Then there's an application at user level that can consume them. You can take trace files, you can do captures, you can do filtering, all this kind of stuff. Filtering in particular, at this point, is sort of like an extension of the Wireshark filtering, but based on the same concepts, right? So with a tool like Sysdig, open source Sysdig, you can do like, I don't know, container ID different from host and process equal bash to detect every time somebody starts a shell in a container. Or you can check for like somebody overwriting system binaries, you know, by just checking the file descriptor.directory property of the system call and making sure that the system call is the right system call. So these are a bunch of examples, but as you can see, the filter expressions have essentially the same identical constructs that you have in Wireshark filters. So essentially take something that works well with packets and apply it to system calls. Now you can do a bunch of interesting stuff, like, I don't know, checking the access to the camera of your computer, you know, by looking at the accesses, IO accesses to the specific video camera device. All right. Up to this point, we're going from packets to system calls. And then, of course, the idea is now that we have something with system calls that looks a lot like we did with packets, why don't we start trying to take what works with packets and port it to system calls? So one of the things that happened in the packet ecosystem at a certain point was that somebody started using packets not only essentially to capture and do troubleshooting like with Wireshark and TCPDump, but to essentially put a rule engine on top of a constant packet capture system to detect, for example, network intrusion. And that was Snort. And now Snort was the first one, but there are other tools that are similar to Snort, Suricata, and so on. So what we did was we did the same, but using system calls, and we evolved essentially from Sysdig to Falco. And Falco is essentially known for system calls. So with Falco, you can create rules, and then you have you are notified when these rules are hit. So again, overwrite the system binary, read /etc/ password, you name it. You know, this is all stuff that you can do with Falco. Falco was created in 2016, and recently, in around last year, we started thinking, okay, we've gone from system calls to packets, and we've clearly demonstrated. Falco, by the way, now is a tool that is downloaded essentially and installed on millions of times a month, essentially. So pretty popular. Same with the open source Sysdig. So we proved that the ideas, the workflows, the concepts at the base of packets can be applied to much more than packets. These are just generally good architectural designs that can be applied to system calls as well. So can we do more? And we started fooling around with the concept of plugins for Sysdig and Falco. So essentially, the overall idea is there's a bunch of stuff that you can, in theory, collect and treat like packets. In particular, logs that are coming from the cloud. So can we modularize essentially this engine so that we are not worried about the data source anymore, and we can apply essentially these concepts to everything. And we came out with an architecture that originally Sysdig and Falco were collecting all the system calls, and we created essentially this plugin system that allows you to write a plugin in the language you prefer, C, Go, whatever, Rust, and import data into Falco or Sysdig and so on, and do it in a way that is sort of opaque to the engine. So the plugins provide both the mean to access the data and the way to decode the data. So when you create a plugin, you create a logic to go and find some data, but also to interpret the data, so that then the engine can just work on arbitrary data. And we applied it specifically to cloud logs. So the idea is in the cloud nowadays, typically you have services like, for example, Amazon CloudTrail. Amazon CloudTrail is a sort of log production and aggregation system offered by AWS. Every cloud has its own flavor of something like CloudTrail, and there are many services like AWS now has over 200 services. All of these generate logs. CloudTrail specifies essentially a common format for these logs that are typically stored in JSON format, and a common place to store these logs that is typically an S3 bucket. So S3 in the cloud is like the cheap storage, right? So this is really great because at this point there is an easy to use, checkboxy, consistent source of data that all of the cloud services that you're using, for example, in a cloud like AWS, are producing and are putting in a way that is really cheap to store them. So you're not worried essentially about how many you're producing. And these logs typically are used for a bunch of, or can be used for a bunch of reasons: alerting, runtime security, incident response, threat hunting, troubleshooting, and so on. Sounds a little bit like Wireshark, right? The way the industry as a whole is approaching this problem today is, okay, take these logs that are put by Amazon on a place like S3, pay Amazon a certain amount for the pleasure of storing them on S3. At the same time, take them, move them to a logging system like a Splunk or something like that. Of course, pay for the bandwidth, which is very expensive on the cloud, and then pay the log provider a lot of money to store these logs, so that you can write essentially SQL queries on top of them, so that you can find if, I don't know, somebody logged in from China without multi-factor authentication in your cloud, right? So it's relatively, at least for the use case, you know, for the Wireshark use case, it's a relatively low frequency use case and very expensive to store all of this data. But also, I don't know if any of you has ever tried one of these logging systems. I just hate doing troubleshooting by doing SQL queries. It's not friendly, it's not iterative, it's not visual, it's not interactive. So it's just not, in our opinion, the right user interface to do something like that. So the idea was, why don't we plug Falco into this? And this is why we started creating plugins. And in fact, the first plugin that we created for Falco was the CloudTrail plugin. And the CloudTrail plugin for Falco allows you to write something like this. I don't expect you to read all of this, but essentially, you know, a Falco rule is very similar to a Snort rule. So you have a description, you have the condition, which is essentially a filter. It's a TCPDump-like filter. And then you have the output, which is a formatting, like, you know, like a Wireshark line formatting, you know, a field-based formatting of the field. That's pretty simple. But as you can see now with this plugin, we can create a condition like cloudtrail.name equal console login. This is the name of the event that we're filtering for. And this is not an error. And the user is doing an assume role. And, you know, there's a console login that doesn't have multi-factor authentication. So this essentially notifies me every time a user logs in without multi-factor authentication. And then Falco will send me alerts by whatever, email, Slack, or send them to a SIM, and so on. So this is something that we launched in Falco last year, actually this year, early this year, to the community, and allows to do a bunch of cool things like monitoring configuration changes, detecting unusual behavior, uncover data exfiltration, and so on and so forth. The other cool thing is that AWS was the first plugin that we created as a Falco community, but more are coming now. So we just opened up the plugin API recently, but like the GitHub one is a pretty cool one, because that allows Falco to just plug into the GitHub API by using webhooks, and then Falco receives all of these notifications from GitHub, and then there are rules like notify me every time a private repository goes public, or send me an alert every time somebody commits something on GitHub that contains a secret, because the plugin can essentially scan the commit message and see which files have been changed, go check the command lines and do error gaps and find if there are secrets there. So a bunch of cool stuff. And there's a public plugin API. Everybody can write its own plugin. So imagine essentially being able to do runtime detection for whatever you want. And whatever, you know, this could be applied to NGINX logs. It could be applied, you name it, you know, to Okta and go check for, or Salesforce, you name it, you know. It's just a matter of being creative with writing your plugin. All right, long story, as I told you. Let's take a look how Wireshark fits into this. At a certain point last year, I was like, okay, there must be a role for Wireshark in this. Let's reach out to Gerald and let's see if we can do something together with this. Gerald?
Sure. Thank you. So yeah, as Laura said last year, you know, he showed me a demo, which ultimately kind of manifested into what we're going to demo today, of Wireshark amplifying this log data to it, and the concept of being able to analyze logs. And you know, if we kind of look at the architecture that Loris was talking about, you know, you have, of course, I'm blocking the screen, sorry about that, but you have Falco, which, you know, which has the Falco libs that it uses. And, you know, Falco libs lets you bring in system calls, has the plugin architecture that lets you bring in all the log data from CloudTrail and Kubernetes and so on. Falco also has this, or Falco libraries also has this really nice API that, of course, Falco uses, but Sysdig also uses, and as it turns out, Wireshark can use, and anybody else can, but that's what we're here to talk about today. Before I get too far into this, let's maybe cover some fundamentals here for like what Wireshark's job is specifically, and you know why it may or may not be appropriate for log analysis. But Wireshark's job, at least as I see it, and I say this all the time, I think Wireshark's job is to help as many people as possible understand their networks as much as possible, and in this case, to help you inspect and understand the traffic on your network, which is a simple enough concept. And as you saw yesterday, there's about 5 million lines of code that go into that, making that simple concept a reality. But it is a pretty simple thing, and it does give us this kind of core goal to pursue when we write code for Wireshark. I mean, we just have this one thing we can focus on when we write code for the application. Now, if I take this blob of data here, it might not be obvious what it is, but I'll tell you, it's a DHCP packet. If we take this DHCP packet and we give it to Wireshark, it does what you would expect. It dissects that packet. It shows you all the fields that are in that packet. It lets you filter them and inspect them and all this other stuff. But okay, we take this. Again, I don't expect you to read text. I'm sure there's probably 2 people in the audience that can. Please just don't say anything. It's annoying. But if we feed this to Wireshark, this is a JPEG file. What's going on here? First of all, Wireshark has a sort of generalized dissector called a MIME file dissector, and it was originally written in order to let you view MIME attachments, like an email or maybe attached to an HTTP request or something like that. But you can also hook the MIME file dissector kind of indirectly into Wireshark's file parser. So you can read JPEG files off your disk. You can read PNG files or GIF files or MP3s. You can read ELF files, which means if you're on Linux, Wireshark can read Wireshark. People kind of don't know about this. If you do have to maybe debug a JPEG file, this would be useful, but I think it's really cool. But at the same time, the utility is limited because you just have the one packet in the packet list, and then this is where you're focusing. But still, it's a cool thing. Along with that, here's the thing. Packet switch networks have been around for decades. And throughout that time, throughout those decades, people have come up with all sorts of interesting and clever and brilliant and truly horrific ways of encoding data on the wire. And as a result, Wireshark's dissection engine has to be able to handle all that. And so we've kind of grown the dissection engine and the dissection API to just handle all these interesting and scary ways that people put bits on the wire and bytes on the wire. And not only, what this effectively means is we can kind of dissect anything for you. If you write the proper dissection code, we can break down whatever you're looking at and give it to you in a format that humans can easily understand and easily parse. And if we go back and look at logs versus packets, I mean, yeah, it's, as I said, looking at files is useful, but you only get one. But if you look at packets versus logs, packets have timestamps, logs have timestamps. Packets have this blob of data that need to be dissected, and logs have this blob of data that need to be dissected, at least in our case. And they also come in all sorts of interesting formats because along with packets, logs have had these decades of time that that have allowed people to come up with really truly horrific ways of encoding log data on the wire and on disk. And so there are all these similarities here, and so I think it really makes a good fit for adopting Wireshark to be able to look at log data. Now, here's another blob of data. You can probably guess where I'm going with this. If we look at this, it's maybe not apparent what this is, but if we load it in Wireshark, hey, this is CloudTrail data. It's a JSON blob that came off of AWS CloudTrail. And the interesting thing here is, we're dissecting it in Wireshark, although this might be Logray, I can't remember. But if we look at the packet detail, okay, there's something called a Falco bridge here. And if you remember a few slides back, there's that Falco libs API that my coworkers created at Sysdig. And that's what we're hooking into here. There's a dissector that Loris originally developed, I guess. But that hooks into the Falco API, and in turn, that Falco API, that library, calls a dissector written in Go, or a plugin written in Go, which is a new thing that we haven't been able to do before. But that Go plugin takes the event from CloudTrail and effectively dissects it and hands it back, and then it goes into Wireshark, and hey, we were looking at CloudTrail stuff. And I think this is going to be really useful. When Loris demoed this to me last year, this was I thought, just an amazingly cool thing, and that's, I was really excited to join the company. So along with that, if we look at what Wireshark does, kind of if we zoom out a little bit and look at it, but what Wireshark does at a top level, we let you capture files, live and do that in real time, and kind of, or at least as near real time as we can give it to you. We let you store packets and trace files, and do all this dissection stuff that I've been talking about the last couple of days. And we also layer on all these other higher level analysis features, and let you customize your columns and all this other stuff. And the overall goal here, the overarching goal, is to improve your analysis workflow. It's to let you look at the packets and analyze these packets in an environment that you're comfortable with, and that you can easily and quickly move across and get down to the data that you're looking for. One of the things I always kind of point out is that with Wireshark, I don't want you looking at all the packets. I want you looking at the interesting packets, and that's why we have display filters and all these higher level dialogues that you drill down in the data, like the IO graphs and things like that. And so, the end result we're at least going for, hopefully, is that you have this investigative environment that's comfortable and fits what you're doing at any given point in time. So the title of the talk is Introducing Logray, and what we've actually done is split Wireshark into a separate application. And luckily, we've kind of coded the application in a way that is modular and lets us kind of do that easily without too much screaming, too much pain. But why would we split this out into a separate application instead of trying to do log analysis in Wireshark? Well, a good example is over here. We have a whole menu that says telephony. It has all these features that are geared towards analyzing packets in a telecom environment. And if we added log analysis to Wireshark, we'd kind of be, well, I don't want to say competing, but I wouldn't want to interfere with people's workflows here. I wouldn't want to be distracting from that. And at the same time, if you do log analysis for a living, if you're kind of a DevOps engineer, I want to have an application for you that conforms to your workflow, a log-based workflow versus a packet-based workflow. And so, we kind of we did talk about this quite a bit, whether or not to do this in one application within Wireshark or to split it out. But ultimately, the wise choice seemed to be to make a separate log analysis application and kind of see where it grows from there into log analysis environments. So we're still early days on this. We're in really early days on this, but I'm really excited to see how this is going to grow in the next few years and see how it's going to be adopted. So it's time for a demo, and while Loris is getting ready for that, I should probably set some expectations.
About the tool or about my demo?
Okay, tell you what, let me ask this question. Who wants to see something dangerous and stupid? Okay, there you go. I learned to ask this question in college. I was part of the juggling club on campus, and there's a whole completely different story because that's how I met my wife. But no, we'd asked this question before we got out the stuff with blades and with flames. And it was just to set the audience's expectations and to kind of get them excited. But as it turns out, for me at least, this is a valid question to ask when I'm giving software demos, because I tend to demo the version of Wireshark that I compiled from the latest source code repository checkout that morning whenever I give a demo. And so that's, like I said, it's a really good question to ask. And today I'm going to kind of kick that up a couple of levels, because not only am I doing something dangerous and stupid by doing a really just kind of bleeding edge release of Logray, I'm not doing it, my boss is. So
so thanks for telling this to me on stage.
having said that, Loris is great at giving demos and he's very graceful at catching errors.
And nothing bad will happen, right? You promise me, right?
Sure. All right. Having said that, on with the demo.
All right. So we are looking at the user interface of Logray, and as you can see, it's Wireshark. And in particular, we haven't even removed, the buttons and the icons that maybe are just specific for packets and so on. So this is still heavily under development, but we've actually opened here. The cool thing about this whole architecture that we described is that it's really the same workflows of packets. In particular, one thing that you can do is you can point these tools to one of these S3 buckets that I was describing before that are sitting in the cloud, and you can specify a filter and you can, or a time interval, and you get a pickup file. And in fact, here I'm opening a pickup file that contains essentially CloudTrail logs. So the user interface is for sure very familiar to all of you, but as Gerald was showing in the screenshot before, instead of looking at packets, we're looking at lines where every line is essentially a different log message that is coming from one of the different services in AWS. In fact, even the columns are different. As you can see, I have a service column here that shows me essentially which kind of service generated this specific log entry. And I also have the region, for example, that shows me exactly in which AWS region these events were generated. And since this is heavily embedded in the Wireshark engine, I can do what I usually do with Wireshark. In particular, this trace file, I took it after realizing or simulating an attack to my AWS infrastructure, where I discovered essentially that there were minor EC2 instances that were running. This is very common. Somebody gets access to your AWS infrastructure and starts Bitcoin miners there, and all of a sudden you have an $500,000 bill because somebody's using essentially your computing capability to start miners. So first thing that we want to do is maybe let's go take a look and see if we can identify those miners. So I have some buttons here with some filters, but one is the EC2. So now essentially we're filtering and we're seeing, as you can see, only EC2 events. Let's actually take a look at the EC2 writes. So I'm combining the two filters, and now I have EC2 events whose read-only type is false. Sorry for the font size. I cannot make the font appear bigger, so I hope it's readable. At this point, as you can see, there's also coloring that shows you all of the right events. And sure enough, if I scroll down, I can identify my miner 001 instance, miner 003, miner 002. So these are a bunch of instances that have been started. For example, the first one has been started at 528, right? So let's go take a look. And one thing that I'm immediately noticing here by inspecting the details of these log messages that it's my name as username that performed this action, but it wasn't me. And if I go take a look at the IP address, actually, this is not a US IP address. This is an IP address from China, right? So something happened, something strange happened here. So let's, right click and just filter on this specific IP address. And we see essentially the activity that this IP address specifically performed in the logs. Notice I can pivot very quickly. I was talking to you before about having to do SQL queries, in your typical log environment or SIEM environment. These are all, this kind of pivoting doesn't exist as a concept, and you typically need to write stuff to do this kind of investigation. Well, here we have the full, essentially, Wireshark power and filtering capability to go and change, essentially, our view on this data very quickly. And of course, we also have the Wireshark efficiency in parsing all of these logs very quickly so that I can do this kind of pivoting. And when I analyze the activity of this specific IP address, I can see that the first thing that is done is it lists the content of a specific bucket called code backup store at 5.25.22 and 5.25.28. Interestingly, it downloads a file called loris.degioanni_accesskey.csv from that bucket. So some idiot called Loris Degioanni probably as a backup for its code uploaded its AWS key in this bucket, and the hacker was able to the attacker was able to identify it. How did that happen? Because that bucket was supposed to be private. A code backup is not supposed to be public. So I can keep, doing my filtering, and this time I select the bucket name, and I apply the filter specifically on the bucket name. And again, there's a bunch of stuff going on this bucket, but let's see what changed on that bucket. So let's combine these with a filter on read-only equal false. And I can see that at 5:22 and 13 seconds, there was actually a put public access block log action on this bucket that essentially went and changed this bucket to become from private to public. This was actually done by me on my IP address. So by mistake at 5:22, I changed that bucket to become public, probably as part of an experiment. And sure enough, if we scroll down at 5:25, this is when essentially the hacker found out that by browsing that this bucket was public, and downloaded my key, and then he started the instances. So we went from essentially just a high level concept that somebody was able to get into our infrastructure, into essentially finding the exact time and the exact action that caused the issue and the consequence of detection. And this was all done essentially by analyzing logs with like in true Wireshark fashion. So this is sort of shows what you can do with Logray, and shows essentially what is our idea. Now, in terms of where we are with this, we started working on this just a few months ago, and it's still very much the experimental phase. What I showed you in the interface is actually real data coming from real logs. So the tool is actually able to read captures and to decode this data using plugins. So every plugin essentially is a little bit like a dissector for the data that is coming. And so it's able to interpret the data and produces the filtering fields, produces the dissection, and so on. Plugins are also able to interface live with the source. So for example, the CloudTrail plugin for Falco is actually able to, if you have your machine configured to talk to AWS, to go and fetch the data from the S3 bucket. Logray is not able to do that yet. So Logray currently works only on captures. It's just stuff that we still need to implement.
Yeah, we need our own version of dump cap. We need like dump log or something like that will pull this data in.
Yeah, and potentially maybe a user interface from Logray that is similar to the capture user interface of Wireshark, but allows you to essentially browse whatever source of logs the plugin might producing, instead of you having essentially to manually create a trace file. And this is, by the way, already in the plugin API, but it's something that is still not leveraged by Logwolf yet. The other thing that is missing here, as you can notice in my demo, is the third pane. And we are actually debating, and we would love feedback on what, for something like this, imagine a Wireshark that can decode arbitrary logs. Again, your NGINX logs, your cloud logs, and so on. What should the third pane contain? The binary is clearly not the right thing because we're not interested in seeing the hexadecimal for a JSON log, right? So Gerald and I are sort of brainstorming a little bit. What would the term pain be, you know, on something like this? And yeah, if anybody from the audience has any ideas, please come and talk to us because this is not set in stone yet. We have a couple of ideas. And of course, at a certain point, we would reach the point of releasing it and making essentially it an open source tool in the Wireshark family of tools. And the goal for us is really essentially, I don't know, try to bring something to the community that from one point of view departs from what Wireshark has done traditionally, but also, I mean, I've not actually before starting working on Logray, I hadn't contributed a line of code to Wireshark for many years, but it's still crazy how you go around everywhere in the world and everybody has used Wireshark, knows the concept of filtering, the concept of captures, the concept of working with that user interface. So I think that it would be very powerful for the broader community to be able to extend these workflows to many more things. And this will not only make the Wireshark family of tools much richer, but we believe that will bring substantial benefit to a community and to an ecosystem that is evolving and evolving fast. Stopping here. So there are 5 minutes, 6 minutes left. So if anybody has comments or questions, Gerald and I are happy to take them.
Sure. Anybody on the console?
So what's the capacity that you're shooting?
So the question is, repeating the question for the Zoom audience, the question is what capacity, what volume are we targeting for this? That's a very good question. I don't think we have a definitive answer yet. One thing to notice is that since Wireshark, and in a general way, the tools that revolve around Wireshark are optimized for something that is extremely high volume with like packets, with something like logs, you can get a decent mileage in terms of what you can do with just, you know, the vanilla tool. Like when, like the ballpark of when something like Wireshark starts to break typically is like 1 million packets, you know, something like that. Plus, minus, you can do more, you can do less, and so on. Doing 1 million log entries in JSON is already allows you to ingest quite a decent amount. At the same time, sometimes, like what I've seen is I've seen S3 buckets with, for example, cloud logs that have, you know, gigabytes and gigabytes of them. So filtering is going to be very important, and we are thinking a little bit about what would be essentially the best paradigm to approach situations when logs are very big. We are strong believers that if possible, we want to leave the events where they are. So we don't want to be in the business of moving like these logs into a different system to index them and so on. But maybe there are ways to do like screening, filtering, quick access to the data that is stored in like cheap storage like S3 when you have massive amount of data without still having to move it. And that would give you access to, you know, a little bit something like a capture appliance that is able to essentially take this data at volume and do accelerated access to this data. For the moment, we need to finalize essentially the Logray tool, and then we'll worry more about the reaching high volumes of this.
We have an online. Okay.
Is this working during capture or display?
To repeat the question, is this working during capture or display? It's very much like Wireshark. I mean, you have the yesterday I mentioned that we have a separate capture process called dump cap, and some other utilities called SSH dump and so on. And you know that process is separate, and you know we do have in the packet world, we have a separate, filter language for that. And I'm assuming we'll want to do something similar with logs. Again, like Lori said, this is still kind of a work in progress and it's still early days.
Exactly. But one thing to underline is like in my demo here, like the filters are that I applied are display filters,
Yes,
essentially.
yes.
So what the plugin does is it gives new display filters to Logray, so to Wireshark, so that these display filters can be used essentially to filter the log entries.
And if you have strong opinions about that, now's the time to speak up.
Do you see a use case of visually correlating packets with logs so that if you're in a PCAP and you see something of interest, say, I'd really like to see the log entries, any logs associated with this IP, right mouse click, off you go. Is that on the radar?
Yes. So first of all, let's repeat the question. Do we envision essentially having these working on packets and logs and being able to correlate packets and logs? So the underlying trace file format that is used here for this demo is pickup-ng. When creating open source Sysdig and Falco originally, and also when working on this essentially extension to Wireshark to process logs, one thing that was very important to me was basing this on the exact constructs that are used for Wireshark, in particular the pickup format. So one thing that this does is this allows you to essentially take logs and transform them in pickup trace files. Because there are many advantages. One is that they are easy to exchange, but the other, and the main reason why we did it that way, is that pickup-ng is a powerful format that, again, has the flexibility to support more than packets. And the vision is that in the future, I don't know when in the future, but that was the original vision, you will be able to put in a single trace file, in a single pickup-ng trace file, packets, system calls, and logs, and then use a unified engine like the Wireshark engine to be able to be the coding and correlation of this data. And that, in my opinion, is the final troubleshooting tool. It will take time to get there, and it will take help from the community, not only in terms of development, but also in terms of envisioning how this will work. But that is absolutely the vision.
With
Cribble, C-R-I-B-L.
I am. So the question is, are you familiar with Cribble? I am personally not. I don't know if you are,
I'm not
Gerald.
either.
It's like TCPDump for log.
Perfect. So yeah, we'll.
Put it in front of their log servers to reduce how much comes in.
Yeah,
Formatting what you want.
we'll check it out.
Thank you.
I believe we're out of time.
Yeah.
Yeah. All right. Thank you very much. And it's been a pleasure.
Yeah.